Welcome to True Projects. In this video, we are going to explain about a project titled Characteristics of Understanding the URLs and Domain Name Features. The detection of phishing website with machine learning methods. And the era dominated by e-commerce, online services, and social media, the surge in phishing attacks has become a pressing concern. Phishing, a fraudulent tactic employed by malicious actors, aim to filter the critical data like credit card details, personal information, and the email credentials, and the social media account data. The gravity of loss inflicted by these phishing assaults underscored the urgency for the robust detection and the prevention mechanism. In response, our discourse underscores the interdisciplinarity of countering the phishing website and exploring the two primary approaches: URL blacklisting and the utilization of machine learning algorithms. While both the strategies hold the merit, our focus gravitates towards the latter, introducing an innovative mechanism leveraging the advanced machine learning algorithm for the identification and the mitigation of the phishing website. In this study, we introduce an innovative approach to enhance the identification of phishing websites. Our project involves the categorization of the internet URL and the domain name, employing the 6 distinct classifier algorithm based on the 11 predefined attributes. Notably, our method streamlines the feature extraction, minimizing the computational burden, and extend its scope beyond the scrutinizing the HTML, DOM, and the URL related attributes by incorporating the analysis of URL and the domain name. To bolster this method, we have curated an exclusive derived from an exhaustive evaluation of an index comprising of data gleaned from globally recognized intelligence agencies and comprehensive organizational resource. And these are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the essential Python libraries and packages required for data manipulation, visualization, machine learning, and the model evolution. And the second one is exploring the dataset. This phase involves through exploration of the dataset containing the attributes of URL and the domain name. Data exploration aids in understanding the distribution, structure, and the characteristic of the data, which inform the subsequent steps. And the third one is data processing. Here it applied to clean, transform, and pre-process the dataset. This includes handling the missing value, encoding the categorical variables, and ensuring the data uniformity. And the next step is visualization using Seaborn and the Matplotlib. Data visualization libraries like Seaborn and the Matplotlib are employed to create the informative visual representation of the dataset. These visualizations provide the insight into the relationship between the variables and the potential patterns that might aid in the model creation. And the next step is label processing. Label processing involves preparing the target variable for the machine learning in the context of phishing the website detection. And this it could entail the encoding phishing and legitimate the label for the supervised learning. And the next step is data splitting to train and test. The dataset is divided into the training and the testing subset. The training set is used to train the machine learning model, while the testing set remains unseen until the model evaluation. The next step is building the model. Here several machine learning models are constructed using the different algorithms to detect the phishing website. The first one is logistic regression. It is a fundamental binary classification algorithm. In this project, it can predict whether the given URL or the domain name correspond to the phishing website or not, but of giving the percentage of accuracy with it. By fitting a logistic curve to the data, it estimates the probability of the input belonging to the particular class in the phishing website detection project. Logistic regression serves as a baseline model to establish the initial prediction based on the URL and the domain name feature. And the next one is LDA. LDA stands for Linear Discriminant Analysis, is a supervised dimensionality reduction and the classification technique. It seeks to find the linear combination of the features that maximally separate the different classes. For phishing detection, LDA include effectively uncover the discriminating features that distinguish between the legitimate and the phishing website based on the URL and the domain name. And the next one is KNN. It stands for K-nearest neighbor, is a non-parametric classification algorithm that assigns a label to a new data point based on the majority class among its K-nearest neighbor in the feature space. And the context of phishing website detection, it analyzes the similarity of URL and the domain name, classifying the input based on the behavior of the closest neighbor. And the next one is SVC. It stands for Support Vector Classifier, is a powerful classifier that aims to find a hyperplane that best separates different classes by maximize the margin between them. For this project, SVC analyzed the relationship between the URL to discern the pattern that differentiate between the legitimate and the phishing website. And the next one is decision tree. It is a tree-like structure that recursively divides the feature space into the segments to make the prediction. Each internal node represents a feature, each branch a decision rule, and each leaf node an outcome. In the context of detecting the website of phishing, decision trees split based on the URL and the domain name attribute, effectively creating a decision path to classify the website. And the next one is random forest. It is an ensemble method that aggregates the multiple decision tree to enhance the predictive accuracy, and it reduces the overfitting and increase the robustness by combining the prediction of the multiple trees. And this project, Random Forest, leverages the URL and the domain name feature to collectively make the prediction, leading to the more reliable phishing detection model. And the last one is voting classifier. It contains the combination of the prediction of multiple individual classifiers to reach a final decision. And the context of this project, it aggregates the output of the different algorithms based on their weighted odds to arrive a consensus prediction. This ensemble approach aims to leverage the strengths of the various models, improving the overall accuracy and creating the risk of reducing the risk of misclassification. And the next one is user gives the input. A user-friendly interface is created using the Flask, allowing the user to input the URL or the domain name for phishing the prediction. And the next one is the given input is pre-processed for prediction. The user-provided input is pre-processed involving the steps like feature extraction and coding to prepare it for the prediction. And the next step is trained model is used for the prediction. The trained machine learning model is used to analyze the pre-processed input to make the prediction about whether the provided URL or the domain name is associated with the phishing website. And the last one is final outcome is displayed. The prediction outcome is displayed to the user through the Flask interface. This output includes the information about the likelihood of the input being a phishing website, helping the user to make informed decision about the website authenticity. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the folders like CSS, fonts, images, JavaScript files within it. And the template folder containing of typically the HTML documents like of index, notebook, result, sign in and sign up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the models are the pickle file which contain the information of the algorithm and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operation. And the signup is a DB file which contains the database for the user to store the user information. And the notebook is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder address. We need to copy this link, cd space and paste this code folder path. By this it will change the country directory to the code folder path. And then click on the enter button. Here we need to write a command, that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title of the project and some information about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some details that are need to be filled. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password, and we need to fill those details. And then click on the sign in button. Here we need to enter the URL. For this I'm opening the new tab and I'm searching for the YouTube. And I'm copying this link address and then pasting this, and then click here and click on the click here button. Here it predicted as our website is 89% safe to use. And by clicking on the URL button, here it will redirect it back to this website. Here we can provide the other URLs too. And providing as of IEEE Explore. I'm copying this link and then paste it on in this website, and then click on click here button. And here it predicted that website is 94% unsafe to use. And in this way we can detect it. And in conclusion, the method for detecting the phishing website using the machine learning algorithms was successful. The random forest model was chosen and the model was applied to a successful dataset, producing acceptable results. The model success was defined as a minimum loss and the data conversion, selecting the appropriate machine learning technique, and the consistency of definitions in the dataset. The final estimation value obtained from the disaggregated test data showed that the model had best success rate in detecting the phishing pages and best success rate in detecting the legitimate internet pages.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.